Once again, my name is Brian Cunningham. I'm with ELPRO Technologies, and I'm based up here in Vancouver. And once again, we are going to be recording this session today. So if I can ask you all to please mute your microphones so any coughs or sneezes are not recorded for all of eternity. And with that said, we'll jump right in. So just thought I would give a quick history of ELPRO. ELPRO was founded back in 1983 by two RF engineers, and they built up a very successful business and then reached retirement age around the year 2007. So they decided to sell the business to MTL Instruments. MTL Instruments was purchased by Cooper Busman in 2010, and then all of Cooper was purchased by Eaton a couple years later. And then Eaton went through a major restructuring and sold off several different business units. And then Aquamonics purchased the ELPRO business a couple of years ago now. And Aquamonics, just for your information, is a company that, it's a holding company that owns a couple of different Australian manufacturers. They hold ELPRO Technologies, as well as another company that manufactures magnetic flow meters, and another one that manufactures irrigation equipment among the collection. And so this is kind of how we you may have seen our radios in a few different brands over the years, and this is essentially how we came to where we are today. Okay, so the applications that the 905 radios are used in span pretty much all industrial realms. So we do a little bit in mining, probably 10 or 15% of the business, a little bit in power generation, probably another 10 or 15%. Then we have oil and gas, and that can be a very large portion of the business, depending on the price of oil. We do a fair bit in agriculture, controlling pivots and things like that. Wastewater is also a very large business. That's probably one of the dominant sectors. And then we have automation, traffic safety, and of course, all SCADA applications usually require radios of some sort. So this is kind of where we're at and the industries we play in. And I always kind of like to show this one here just to give you a rough idea as to where these, what is the purpose of our products and what function do they perform in industry. Traditionally, we would have had, for example, a flow transmitter on the left-hand side with a 4 to 20 milliamp signal buried in steel conduit, running some distance back to the control room, where we would have a flow indicator, maybe a chart recorder, maybe a display, or going into a PLC or a DCS system. Well, we now replace that with radio telemetry, with using a pair of radios in between. And we do so when the cost is less than running signal cable. If running a hardwired signal can be done for less money than using a pair of radios, then we advise doing so. It is when a radio system is less expensive or a cable simply cannot be run for any number of different reasons, either moving machinery or possibly might be simply too expensive, or might simply be too much distance in between the two locations there. So this is where radio telemetry comes into play and can save a tremendous amount of money. Okay, so ELPRO products, they're designed for industrial applications. And here's a couple of firsts that we have, that ELPRO has done. We own multiple patents registered in many different countries. I know we've got patents in Canada, the US, and Australia, probably a few other countries as well. And a lot of these are related to some of the firsts that we developed here. We were the first to develop a true peer-to-peer industrial networking system, where the master radio no longer had to control all communications and acted as a sort of a Achilles heel. If the master radio ever went down, you lost all communications, but not in a peer-to-peer radio system. And we were also the first to come to market with a 900 megahertz, 1 watt, self-healing, self-organizing mesh network. Other companies had done so at higher frequencies, but nobody had put it on a long-range 900 megahertz platform with 1 watt of transmit power at that time. We were also the first to market with a 900 megahertz long-range 802.11 Ethernet wireless system, which was quite unique in the marketplace. So we're focused on the industrial market, and what that means is that all of our radios are Class 1, Division 2, UL and CSA approved. Temperature ratings go from -40 to plus 140 degrees Fahrenheit. So these are designed to be left in an electrical enclosure out in the middle of nowhere without a heating system. These radios are FCC compliant. We have ATEX approvals, CSA UL, CE for Europe, AES encryption, et cetera, et cetera. Okay, now before we jump into the 905 series, I'd like to just show this slide, which shows a breakdown of our portfolio. So across the top row, these are what we call the remote I/O radios. And all of these radios have 4 to 20 milliamp inputs and outputs. Then across the middle row, we have our gateway type devices. And all of these radios can communicate using a protocol like Ethernet, Ethernet IP, or Modbus TCP, etc. Across the third row, these are our Ethernet pass-through modems. So whatever you stick into the Ethernet port of one radio comes out the Ethernet port of the opposite radio. And then finally, we have our serial modems, which essentially do the same thing. Whatever you stick into the serial port of one radio comes out the serial port of the opposite radio. And then lastly, we have our cellular modem, which enables connectivity to a machine anywhere in the world that has internet access. So you can dial into Verizon or AT&T's private network from anywhere in the world. You've got connection to the internet, and then access your machine, which is connected to one of these Ethernet ports here. So very interesting, very powerful capabilities with these cellular modems. And then lastly, in Australia, we have a SCADA solutions group where they will design a turnkey radio system for you. Again, that's offered in Australia only. Today, we're going to talk about the radios that have 4 to 20 milliamp inputs and the gateway type devices. And specifically, we're going to be talking about the 905U generation of radios. So now we have since then superseded with them with the 915U2. But there's a number of very unique capabilities to this product series that we're going to talk about today, which is one of the reasons why these radios, why we've sold so many of these radios. Okay, so the 905 radios are going to be these devices in the upper right-hand corner. So that's what we're going to be talking about today, how to configure and set up and the capabilities of the 905 generation of radios. Okay, so there are 4 different types of 905s that we have on the market today. We have the single I/O unit, the 905UK, as well as the 905 ULT and ULR. So this is the 905UK unit right here. It's a transmit-only device. You can see it's in a weatherproof housing. And over on the right-hand side, this is the 905 ULT for transmitter and R for receiver. And again, these devices, they're all one-way. So they either transmit or receive, but not both. With the 905UG and the 905U-1, these are transceivers. So they both transmit and receive information. Then we have our serial expansion devices, the 115S serial expander modules. And these will connect to any of the two-way radios to the RS-45 port on each module, and they expand the I/O capability of the radio system. And we'll talk about those in just another few minutes. Then we have our gateway radios, and this is the 905UG devices. And they have the capability of talking Ethernet IP, as in Allen Bradley's Ethernet IP, or they can talk Modbus TCP or a Modbus RTU, as well as Allen Bradley's older DF1 serial protocol. So we'll chat about the gateways in a couple of minutes, but these are the family of 905U radio systems. Okay, starting with the 905U-K. This is a one-way transmit-only radio. So it cannot receive data. It just goes ahead and transmits whenever it detects a change in state. And it has one analog input and two digital inputs. The analog input can either be current or voltage, but most commonly it's going to be a 4 to 20 milliamp signal wired into the radio. We also have the option of pulse inputs for the digital input. So we have two digital inputs here, and they can be either discrete or digital, or record pulse signals from like a turbine type flow meter or a kilowatt hour power transducer. What is unique about the 905U-K is that it has a sleep mode, which can preserve battery life and puts the unit into a low power consumption when it is not taking a sample. Now, with the discrete inputs, the radio continuously monitors the status of these discrete inputs regardless of if the radio is in sleep mode or not. If either of the two discrete inputs changes state, the radio will wake up and go ahead and transmit that information over the air, over the antenna port. In sleep mode, what it will also do is it will cut power to the 24-volt loop supply. So this is another interesting thing, is that despite the radio being powered from 6 to 30 volts DC, it will take that voltage and produce 24 volts for a loop-powered 4 to 20 milliamp instrument. So imagine if you have 12 volts going in, the radio internally bumps up that voltage to 24 volts and then powers the two-wire loop-powered instrument. So this is kind of unique. It's very flexible in terms of it doesn't matter what the power supply going into the radio is, it always will produce that 24 volts coming out. Now, when the radio goes into sleep mode, obviously it's not sending any data, so it cuts power to the 24-volt loop. And in so, it preserves your battery that powers this radio system, or the solar panel. It cuts the power consumption required. So very unique capability. Then when the radio is ready to take a sample, it wakes up, it turns on this 24-volt loop supply. It waits a programmed time period for the two-wire sensor's reading to stabilize. Then it takes a sample and goes ahead and transmits that over the air. So very unique capabilities. It's also, as we mentioned earlier, housed in an IP66 NEMA 4 enclosure. So this unit can be left out on its own, does not need to be placed inside of a typical electrical enclosure. Okay, now we also have created a new option for the 905U-K. This version of the 905U-K comes in this weather-tight enclosure, and it houses a battery inside of the enclosure. It has connections for a solar power, a solar panel. So all you would need to do is just wire up the solar panel, connect your 4 to 20 milliamp loop instruments and any discrete inputs, and presto, that unit is ready to go. Oh, I should mention, and connect the antenna as well. So very unique capability, ruggedized aluminum enclosure, completely sealed, provides a couple of cable pass-throughs at the bottom, and some unique capabilities. This unit has 4 digital inputs instead of 2 on the standard 905U-K. As well, it also has a single 4 to 20 milliamp analog input. It also has an SDI input for any SDI sensors like weather instrumentation. The internal battery is a rechargeable lithium battery housed inside of the module. And the battery itself would power this radio for a couple of days on its own. And then, of course, you can connect the solar panel to be able to charge that internal battery. It can also provide loop power to, that should say 4 to 20 milliamp instruments, just as the 905 UK can. So regardless of the power supply voltage, so typically it's going to be 12 volts for this system here, it will bump up that voltage to 24 volts to provide power for your 4 to 20 milliamp instruments. And just like the 905 UK, as we chatted earlier, it will turn off that loop power when it is not taking a sample. So very unique capabilities and newer device. A lot of interest we've seen in this particular product here. Okay, next is the 905 UL-T and the 905 UL-R one-way transmitter receiver pair. Now both radios look identical. The only difference, one of them does not have the signal button, but very simple, very straightforward transmit receiver pair. So these two devices can be paired together without software. So all you do is you press and hold the signal button, you cycle power on the other end of the radio system, and the LEDs go through a little bit of a flashing sequence, and next thing you know, the two units are paired together. They have one analog input and two digital inputs on the transmit unit, and then one analog output and three digital outputs on the receive unit. The extra digital output is designed for the RF link status. These modules can take digital, analog, as in 4 to 20 milliamp analog signals, pulse signals, as well as a thermocouple input into the transmitter. On the receiving end, the receiver, the outputs are relay outputs, and they're all rated at 240 VAC, so you can directly wire a higher voltage AC power to the relay outputs on this unit here. So very inexpensive, very simple unit. You can see it just mounts on a DIN rail at the back there, terminal block across the bottom, and then you've got your LEDs on the front. One thing that's really cool about this is if you're ever wondering how strong the radio signal is, just press and hold this signal button down, and the more LEDs that light, the stronger the signal is. So just like your cell phone with bars, more LEDs means the stronger signal. Okay, then we have the 905 U-1, which is a multi-IO transceiver. This radio is probably the workhorse of the ELPRO product line for many, many years, for probably a good 15 years or so. We have sold literally hundreds of thousands of this ELPRO 905 U-1 to customers all over the globe. It has 2 analog inputs, 2 analog outputs, and also 4 digital in and 4 digital outputs. And then we have LEDs across the top here that will show you the status of the outputs, as well as the status of the inputs across the bottom here. And then a couple of diagnostic ones. We've got the OK LED and the power LED, and then the TX and the RX for when the radio is transmitting and receiving. So this radio also can power a 2-wire sensor, or it can accept externally powered 4-wire loops. So it's very flexible. Pretty much any type of 4 to 20 milliamp instrument can be connected to the radio system here. Digital input 1 can also accept a pulse input, so could be used as pulse or digital. This radio has a solar charge regulator built directly into it, so it can have a 30-watt solar panel and a 100 amp hour battery wired directly to it. So all we do is for the solar panel, we connect it between the SOL and ground terminals, and for the battery, we connect it between the BAT and the ground terminals. And by doing so, the radio no longer needs standardized 24-volt power. it will operate just off of a 12-volt system. Guys, if I can just to remind you, we are going to be recording, or I should say we are currently recording today's session. So if I can just remind you to make sure your microphones are muted for any late comers to today's webinar. We have two power connections to this radio. If the power supply is between 15 and 30 volts, in other words, a nominal 24-volt power supply, we connect it between SUP1 and ground. If the power supply is between 9 and 15 volts, in other words, typically a 12-volt power supply, we connect it between BAT and ground, battery and ground up here. So keep in mind there are two separate power inputs to this radio. And the reason we have these two separate inputs is because it's designed to have a battery connected to power the radio when primary 24-volt power is lost. So when we have 24-volt power connected here, it puts out a trickle charge onto the battery and ground terminals to charge up your battery. When 24-volt power is lost, the radio system is then powered off that battery. So essentially, this provides seamless operation, whether 24-volt power is available or not. Okay, then the next product we're going to talk about is the 115S serial expansion modules. And there are three different modules with different I/O combinations. The 115S-11 has 16 DIO. Now, when we say DIO, that means it can be used as an input or an output. And it just depends on how you program the radio. So we could have 15 inputs and 1 output, or we could have 7 inputs and 9 outputs. Any combination of these 16 DIO can be used. On the 115S-12, we have 8 analog inputs as well as 8 DIO. Then on the -13, we have 8 analog outputs plus 8 DIO. So very interesting units. We can have up to 10 of these modules connected to the 905U-1 or the 905U-G series. And if these modules were used on their own, up to 32 of them could all be daisy chained via RS-485 to a Modbus master device. So these devices can use two different protocols to communicate. If you set the rotary switches, which are across the bottom here, to 00, they will use ELPRO protocol, which is what the 905UG and the 905U-1 use. If you set the rotary switches to anywhere from address 01 to 100, it uses Modbus RTU slave protocol. So we could use these devices independent of our radios with any Modbus RTU master device. And again, this is if we use Modbus, we can have 32 of these devices daisy chained together. If we use ELPRO protocol, we can have just 10 of these devices daisy chained together. But keep in mind, with 8 analog inputs, if we had 10 of them, that would be 80 analog inputs. So really very large I/O capability with this module setup here. Okay, as I mentioned earlier, it communicates over RS-485. So up to 32 modules could be connected together by the RS-485 or by the Modbus standard, or RS-485 standard rather. So very simple daisy chain, two wire twisted pair going from radio to radio to radio. Okay, one other interesting capability is that we do have a software program for the 115S, and it allows you to determine whether the radio powers the 4 to 20 milliamp loops or it accepts powered 4 to 20 milliamp loops. We can also set it up for sync versus source. So it can either source the 4 to 20 signal or sync the 4 to 20 signal. Okay, the next product to chat about are the 905UG gateway radios. We used to have quite a few different models in the past. Today, we've narrowed the product line down to two gateway models, the ET1 and the MD1 gateways. The difference between these two modules is the ET1 has an Ethernet port on it, whereas the MD1 does not. So the ET1 can communicate using Allen Bradley's Ethernet IP protocol, as well as Modbus TCP. The MD1 gateway can communicate using Modbus RTU or Allen Bradley's older serial protocol, DF1. Now, these radios can act as protocol conversion devices. And the way that works is if we had Ethernet IP going into one radio at one section of a plant, what we do is we convert that data into ELPRO's database. Then we transmit that information over the air. The opposite radio then converts that information into Modbus database format. So in doing so, we have now converted data from Allen Bradley's format into a Modbus or Schneider Electric or Modicon format. And in doing so, we can allow PLCs of different legacies to communicate. So now you can have your Allen Bradley PLC communicate with your Schneider PLC. Commonly, what happens in a plant is over a 5 or 10 year period, they may have installed Allen Bradley equipment. Over the next 5 or 10 years, they may have decided to move to Modicon or Schneider equipment. And this is very common, is what we see is plants often have a mix of different types of control equipment. And our radios allow you to convert from one to the other. These radios have 10,000 registers on board. They are divided into 5,000 registers for I/O values. So these are going to be from 4 to 20 milliamp signals at remote radios or discrete values, etc. And then we have another 5,000 registers, which give you the status of each register. So for all these I/O points here, they're going to be coming from different radios. So we can have comms status, we can have the received signal strength indication. We can get all kinds of information out of the status registers, which reflect the status of the I/O registers. Now, one thing I have not really mentioned or emphasized too clearly is that all of the 905U radios can communicate with each other. So very commonly, I'll have out in the field a 905U-K. It'll be sending its data to this gateway, which is connected to a PLC or a DCS. I could also have a 905U-1 with a couple of analog inputs and a couple of analog outputs, also exchanging its data with this 905UG. And maybe in some sites, I might have a 905ULT transmitter, just picking up a single analog value and also sending it to this gateway or possibly to another 905U-1 radio system. So all the radios that start with a 905 can all communicate with each other. Okay, across the bottom of the radio, we have 8 DIO. And they can be used as a digital input or a digital output. And then, of course, we have our standard 24-volt power, and then we have our battery power. So again, we normally power this unit off of 24 volts, but we can have a battery backing up this radio such that if the 24 volts is lost, the battery takes over and we have seamless operation without the need for a UPS. Generally, these gateways either communicate between PLCs or they're used as data concentrators in larger networks. So the 905UG radios are typically going to be located in the control room. Okay, in a couple of minutes here, I'm going to jump into the software and show you how this works, but we have some diagnostics for a lot of these radios. For the 905UK and the 905ULT transmitters, we have the ability to read inputs in our E-Series configuration software. So what this allows you to do is it allows you to see how many milliamps does the radio think is going into it. And then we can compare that with the output of the temperature transmitter or the level transmitter or whatever variable is being measured. And we can see if the radio is functioning properly. Is it measuring those values correctly? Okay, so that's kind of a useful thing. It also tells you your battery voltage and this sort of thing. So it gives you some basic diagnostics here. With the 115S, we also have the same inputs, or same capabilities rather. We can read the analog inputs, and this will show you in byte counts what the 4 to 20 milliamp inputs are all doing. So quick way of reading the inputs, run this configuration software, log into the radio, and then you can see, is the radio seeing the same signal that the sensor is outputting? Okay, then we have communications logs, which we typically do on the 905U-1s or the 905U-G type radios. And what we should see is we should see a standard staccato pattern. So for every transmit, there's going to be a receive, an acknowledgement that comes back. So in this case, we can see if we look at these individual lines here of this communications log, we can see healthy transmit receive activity. The radio sends a message out, and the opposite radio acknowledges it immediately upon receipt. If the opposite radio did not acknowledge it, we would see this transmit message repeated 5 times over. So these radios, if they don't get an acknowledgement back, or the two-way devices, if they don't see acknowledgement come back, they will go ahead and resend that same message. They'll go ahead and send that message 5 times before giving up and discarding the message. Okay, and what they do is they back off a random period of time. So if the first message does not receive an acknowledgement, it'll back off maybe 200 milliseconds. If the next message is not acknowledged, it'll back off maybe 500 milliseconds, et cetera, et cetera. And that allows for a very busy radio network to eventually allow these messages to get through. So that's one of the things we're looking for, is we want to see if any of these transmit messages are being repeated again and again and again. And that would usually indicate we have a poor radio path, or the remote radio is powered off or has lost its antenna. Then we have this negative number at the end of every receive message. This is the radio receive signal strength in dBm. So this is telling me this radio is getting a signal of negative 77 dBm. So that's a very healthy, strong signal. So everything seems to be okay. It's also not doing any retries here. So we can see this is a fairly healthy system. Each message comes back. The RSSI is relatively strong. So communications appear to be solid. Now, there's a number of different things that we look at with these communications logs. And oftentimes, if a customer is having difficulty, what I will do is I will send him instructions on how to create a communications log, and then ask him to email the communications log along with the configuration for this network of radios to me. Then what I will look at is I will look for, obviously, we'll make sure there's suitable signal strength, but we'll also check the system address. Quite often what might happen is a new network might be installed adjacent to an existing ELPRO radio network. So the two radios might be able to hear each other. So oftentimes, if we click on one of these lines here and we observe in the box below the system address, this may not line up with your system address, in which case these messages would just be discarded. Some of the other values we can look at are, we can look at the unit address of each radio. And each line, if we click on it, it'll show you whether it was an outbound message or whether it was an acknowledgement coming back. And it'll tell you between which two units. So normally we would want to see an outbound message go from unit 1 to unit 2, and then we would expect this acknowledgement to come back from unit 2 to unit 1. As well, we can click on the analog values. We can have a look at the 4 to 20 milliamp signals, so we can see what values are being sent over the air. So we can check that as well. But generally what we want to look at is we want to check the system address to make sure we're looking at our network. We want to look at the received signal strength. And then we want to see if the radio has done any retries. In other words, if we see 4 or 5 of these transmit-only messages all repeated in a row. Those are the most important things we're looking for. Beyond that, we'll look at the message count, and that is how many messages in a single minute are being sent by the radio network, because we do want to allow for open airspace for radios to send messages to us. So there has to be a little gap in time so that a radio out there, if he's got a message and he's been waiting for somebody else to finish transmitting, there has to be a gap in time for him to be able to get his message out over the air. So that's why we we recommend a maximum message count of 100 messages per minute for this generation of 905U series radios. And that allows for plenty of airspace for other radios to go ahead and transmit their data back to the gateway or the master radio. Okay, so that gives you a rough idea as to what we're looking at for diagnostics here, and what sort of capabilities, what we're trying to check for. So yeah, very interesting. You can really dig down. And fortunately, we have this converter. It converts all of this hex information into something we can understand down here, into what the command type is, what the system address is, what the unit addresses are, and the 4 to 20 milliamp or discrete signals as well. So some very good, real depth you can dive into with these radios. Okay, so I think we're finished with the PowerPoint part of this presentation. So just bear with me for a minute here. I'm going to stop sharing for just a minute here, and then we'll go to the software here. Okay, so I've stopped sharing my PowerPoint screen, and now we're going to show the wireless I/O and gateway configuration. And one thing I see is I do not see the red line outlining my screen, which tells me that you can see this. Matt, I was wondering if you could just give me a verification. Can you see the wireless I/O and gateway configuration software?
No, sir. We are looking at a black screen.
Yep. Thank you, sir. I'm just going to go ahead and stop that sharing option, and I'm just going to share my entire screen here. Okay, so we're going to share my screen. And Matt, oh, there we go. Now I see the red outline of my screen telling me that I am sharing it with my audience. And Matt, I assume you can see the screen now as well.
That is correct.
Perfect. Okay, so this is the wireless I/O and gateway configuration utility. This is our software. It is free to download off the ELPRO website, and it is what you would use to configure the 905 series of radios. So what I've done here is I've just created a blank project template here. The software automatically assigns a system address, and this system address is a random number between 0 and 32,000. If the system address is an even number, the radio network will use the 902 to 915 megahertz frequency band. If the system address is an odd number, it will use the other portion of the 900 megahertz band, the 916 to 928. So in doing so, it's very easy to separate radio systems from one another. So if we know there's another radio network in the plant, what we should try to do is find out what its system address is And if it's an even number, we would just make sure we set our system address to an odd number. And therefore, these radios will not even hear each other. Okay, then the next step is to click under Units here and begin adding the units to the project file. Now, if I wanted to pull the configuration from an existing radio, from the radio into my computer, I would click on Load a New Unit, and it'll pull the configuration out of a unit and put it into the software. If I click Add a New Unit, it allows me to add all these radios to a project file and then download them to the each individual radio one by one. Now, when I'm selecting my unit type with the 905UG, it's going to ask you which variant of the 905UG we have. The most common one is the 905UG ET1, which has an Ethernet port on the radio and can do Ethernet IP as well as Modbus TCP. So we go ahead and hit OK. And it also has the option of manually selecting the unit address. So there's a system address, which all radios must have the same. And then there is a unit address of which each radio must be different. So I'm going to let the software select the unit address for me. And all it does is it starts at address 1 and increments up. So I'll go ahead and add a few more radios to this project tree. Note that we dropped the U out of the model number. So if we have a 905U-1, just select 905-1. Okay. And we'll let the software set the address. And just for kicks, I'll add a third radio to the project here. And we'll make it a, in this case, we'll make it a 905U-K unit. Okay, so now we have 3 radios added to the project tree. And if I click on the plus sign, you can now expand all of the options for these for each radio. Okay, now the most important option for every radio is the mappings. And this is how we transfer data from one radio to another over the air. So all I do is I click New I/O Mapping, and I select which input I'd like to map. I select the destination radio, and because it's a gateway, I have to tell it what address I would like the value to be stored in. To keep things simple, I'll just select address as 0 and hit OK. Okay. So now analog input 1 from this 905U-1 is going to be wirelessly transmitted to this 905UG, and it's going to be stored at register number 0. If I had any repeaters in the path, I would enter those repeaters right here. Okay. Then we have a pole mapping. And what this is this is a startup pole. So what I can do is I can set this unit so that when it is first powered on, it will say, hey, 905UG, I was just powered on. Can you go ahead and send me the status of any outputs so I can update my 4 to 20 outputs and discrete outputs? This allows the radio to come online much faster than waiting for these analog values to be transmitted over the air. So startup pole means as soon as this radio gets powered on, he's going to pull any other radios that it has a mapping to, or specifically this 905UG, and he's going to say, hey, I've got a couple of analog outputs here that are being sourced from this radio. Go ahead and transmit those values to me so I can update my 4 to 20 and discrete outputs. Okay, so if we're sending, for example, in this unit right here, what this message is telling me here is that because I created this new mapping over here, I have to program both my source radio and my destination radio for this mapping to take effect. Okay, now with the 905 UK, for example, it's even simpler to send a value across to the to another radio. If I wanted to send it from the 905 UK to the 905U-1, as soon as I click the 905U-1, it tells me all of the outputs that are available. So I just select the input, the destination radio, and then the output on that destination radio. So creating mappings with the 905U series is really very, very straightforward. You just work from left to right. Okay. The next feature we have is update times. And this determines how often this analog input will be transmitted over the air. Now, these radios rely on change of state. So what they're doing is they're continuously monitoring all of these inputs. And if any of them change, those values are transmitted immediately. So this update time really is just a heartbeat communications. Now we can set it to any time we like. So I can change this from 10 minutes. I can just set it to have it transmit every 1 minute or something like that. But again, it is not necessary to set the update time to something very rapid, like every 5 seconds or every 10 seconds, because the inputs are constantly monitored. And if they change, they will be transmitted immediately. Now, the question next that comes up is, how much does the 4 to 20 milliamp have to change before it is transmitted? And that is set under the sensitivity. So with the sensitivity set to 3%, that equates to half a milliamp. So if this 4 to 20 milliamp channel changes by more than half a milliamp, it'll go ahead and transmit that value over the air immediately. And of course, we can change that. We can make it a little tighter, a little wider, etc., depending on what is being measured. Okay, then we have our output reset times. And remember over here, we're sending analog input 1 to analog output 1 on this 905U-1. Well, what happens if this 905 UK loses power, or the antenna gets knocked over, or it gets pulled from service? What do we want to happen to that 4 to 20 milliamp output if communications are lost? Now we have two options. We can either have the 4 to 20 milliamp output flatline, so it'll just freeze at the last known value. And that's what happens if we have this output reset disabled. Or we can set this output reset to a certain time frame. Now remember, our update time, the default is every 10 minutes. So I'm going to set this output reset so that after 11 minutes, this output will go to 1 milliamp. So in this case here, if this 905U-1, if analog output 1 does not receive an update, within 11 minutes, it's going to go to 1 milliamp. Now we set that value to 1 milliamp because we didn't want it to go to 0 milliamps. Otherwise, customers would think it is a broken wire condition. But 1 milliamp lets you know that it is outside of the standardized 4 to 20 milliamp range, but the signal is still there. It is still wired. It is still good, but it is in communications failure. So we can do that with all these outputs. With the digitals, we have the option of freezing at the last known value or turning off if communications are lost. Okay, then we have some pulse input options. We have some pulse output options as well. Then we have our set points here. And what this refers to is triggered off analog input number 1. So set point 1 will monitor analog input 1, and it allows you to map the set point to a discrete output. The idea here being that it monitors the analog input. And when the analog input exceeds 70%, it turns on the digital output that you map it to. When the analog input drops to 30%, it turns off the digital output. So the way to think about this is that it's designed to fill a liquid storage tank, like a water storage tank. So when the output gets to 70%, let's see if I'm explaining that logic correctly. When the output is at 70%, we want the pump to turn off. And when the output drops to 30%, we want the pump to turn on to fill the tank, to bring it back up to this high level. So I'm sorry, I think I explained that wrong initially, but if you view it from the perspective of filling a tank with a pump, the pump will turn on at 30% and it'll turn off at 70%. Okay. So the set point is mapped by using our I/O mappings here. So in this case, set point number 1 is monitored off of analog input 1, and I can set it to any remote radio, for example, this 905 UG, and I can set it to register number 1 to function as a digital value. Okay, so that's our set points. Then we have our debounce here. Again, just a quick message telling me which radios I need to program for that new mapping to take effect. And the debounce here, this refers to a slight delay that the radio applies to either an analog change of state or a digital change of state. For digital signals, it's to allow for contact debounce. And what this does is this applies a half-second delay. So when the relay of the digital input changes state, 0.52 seconds later, that value is transmitted over the air. Once it's confirmed that that wasn't contact bounce, it was in fact an actual change of state of the digital input. For the analogs, similarly, it just waits a half second to make sure that any change of state that we saw on the analog channel was not just a temporary spike, that it was indeed a valid change in the 4 to 20 milliamp signal. Okay, lastly, we have our serial units. So we mentioned we have our 115S serial expander module that can connect to the RS-45 port of the 905 1 or the 905 UG. And if we had serial units connected, this is where we add them to the network. So we tell it what type of module we have connected, and presto, we now have an extra 8 analog inputs on this module, as well as 8 additional DIO. The options for the 115S modules, virtually the same as the 905U series. As you can see, we can click on mappings here, go to new IO mapping, and now we can see all of those inputs or outputs that we have available on these expansion modules. Okay, so if I want to send a digital input 1 to this 905 UG, I just go ahead and select the input, the destination radio, and then the output at that destination radio. Now note that the 905U-1, that this module is going to be wired to via RS-45, this guy right here, is entered as a repeater. And this is just how these networks work. The 905U-1 receives the message from the 115S-12 and just immediately repeats the same message over the radio channel. Okay, so again, all the same options that we have on the other radios here, and presto, we can increase the IO count of this 905U-1 very, very easily. Okay, so back to our gateway radio here. The gateway has very similar options. We've got, we can transmit its discrete IO or just an individual register over the air. We can also do block mappings between gateways. So if I wanted to select a new, if I wanted to transfer a block of registers, like 20 or 50 or maybe 100 registers from one radio to the other, this is how we would do so. So we select our command type, and we can either write, and you can see in that case the flow of data is in this direction, or we can either read. And the only difference is the flow of data is now in the opposite direction. Then we just tell the radio whether we're sending 16-bit words for analog values or whether we're sending bits for discrete or digital values. Okay, so we once we select the command type, then we would go ahead and select which registers did we want to go ahead and transmit. Now, this legend here tells you what I/O registers are being used for what purposes. So it's quite useful. It tells you if an I/O register is already being used for a specific purpose there. But I can just go ahead and select I/O register number 1, hit apply, and then we select the I/O count. So if I wanted to send 3 registers over the air, this is now going to send registers 0, 1, and 2 to this destination gateway radio. Then we have the period, and this is how often these values are transmitted. So, we can set it every couple of minutes, or we can set it to continuous. And in this case, the offset determines how often this radio transmission is made. And in this case, it'll be made every 5 seconds. This block of 3 registers will be transmitted from the source gateway here over to our destination gateway. So that's how we transfer a block of registers between gateway radios. Okay. Now, here I'm going to jump into the Ethernet settings because this is an Ethernet-based gateway here. It can communicate using Allen Bradley's Ethernet IP if we enable this box, or it can communicate using Modbus TCP if we enable this checkbox right here. Then we have a bunch of options that we can set up here. So this radio can be queried using Ethernet. Normally, these radios are programmed via a serial cable. So today, what that means is we use a USB to serial converter cable, and then we plug into each radio's RS-232 port, and we go to the command line of each radio, the headline of each radio, and we click on Program Unit. And this sends the configuration from the software into each radio. The opposite is loading a configuration, and this pulls the configuration from a radio into the software so that we can review it. And then lastly, we have our diagnostics menu here, which I gave you a glimpse of it during the earlier PowerPoint session here. But this is how we create a communications log and how we analyze all these different types of commands here. Okay. So that's how we program the radios here. And if we have our Ethernet address already programmed into the radio, we can also access these radios via Ethernet from this menu down here. Then we have our update times, which all of the radios have. We have our communications failure times, which is the same function as output reset. Output reset and communication fail times are the exact same function. And so after we set our Ethernet settings on this radio, we tell it what protocol we're going to use and this sort of thing. I'll use, for example, Modbus TCP as an option here. There is one final step that we have to do to make these radios communicate with a PLC using one of those protocols, and that is we have to create field bus mappings. So we have 2 different databases inside the radio. We have the radio database, and then we have the field bus database. And guys, we're about 2 or 3 minutes from wrapping up this presentation. I see we're pretty much at the top of the hour right now. 2 or 3 minutes will be finished here today. The radio interface, this database has all the mappings to and from all of these remote radios, and stores all of this data as either analog or discrete values. Then we have our field bus interface, which does the Modbus communications or the Allen Bradley's Ethernet IP communications. So we have to transfer the data internally in the radio from one database to the Modbus or Ethernet IP database. So we start with our command type. We either read the data or we write it. So this determines which direction the data is going to flow. Then we have to select the I/O register that we want to send over the air. So I'll make it nice and, to transfer it to the field bus database, I'll make it nice and simple and start with register 0. And let's say we had 3 registers that we wanted to transmit to the field bus interface. Then we select either word or byte or single bit mode, depending on whether it's a discrete signal or an analog signal. And then we have the location on board the field bus interface that we want that data to be stored. And in this case, I'm going to have it stored in registers 0 through 2 to have those 3 values sent across. So once we have transmitted or sent our data to the field bus database, it can now be read using Modbus TCP or Allen Bradley's Ethernet IP protocol. And with that, I've pretty much covered all of the major settings of this radio here. There's lots of individual settings. We can certainly go into these radios in much greater detail. They have a lot of very powerful, very capable features. But today, at least, we hope we've got you started. You have a rough idea as to what these radios can do and how to configure them and how to set them up. So with that, I'm going to conclude today's webinar.